this lesson, we're going to look at sets of data, and we are going to look to see the relation that two sets of variables have in common. So in this first example, it says that the data listed in Table 6 represents the apparent temperature versus the relative humidity in a room whose actual temperature is 72 degrees Fahrenheit. All right, so we have two variables here. The first one is the relative humidity, and this represents our x values, and I drew a graph and labeled my x-axis as relative humidity, and it's measured in percent. And on our y-axis, we have the apparent temperature, which is measured in degrees Fahrenheit. So if we were to take those two sets of data and plot the corresponding values together, we're going to make a scatter plot. So doing that, though, we need to label our axes, and this has been a real tricky thing that I've seen that my students in the past have had a hard time understanding. But if I am labeling my x-axis from 0 to 100, okay, I want to use as much as my axes as I can. So I'm going to say that this is 100, this is 0, halfway in between would be 50, 60, 70, 80, 90, 100, 10, 20, 30, 40. So I have as equal of intervals as I can get on my x-axes, just kind of spreading them out. And on my y-axis, we can see that our range values go from 64 to 76. So do I have to start at 0? I do not. But I know that maybe I'll have like a little broken line here. Maybe I'll start at 50, and I need to go up to at least over 76, so maybe I'll go from 50 to 80. So here's 50, 60, 70, 80. Okay, so I'm splitting them as evenly as I can to make the most use of the graph space that I have. And then I'm just going to do a real quick plotting of the points. 0 to 64, 10 to 65, 20 is 67, I'm going up, 30, 10, 20, 30 is up to 68, 40 is at about 70, 50 is at about 71, 60 is about 72, 70 is about 73, 80 is about 74, 90 is about 75, and 100 is about 76. All right, so we can look at this and we can see that as the relative humidity increases, so does my apparent temperature, or the real field temperature. So if I were to write that as a sentence, okay, so here we drew the scatter plot. We're going to do this using the graph utility in just a bit. We're going to use Desmos to get a graph on this. So describing what happens to the apparent temperature. So as the humidity, the relative humidity goes up, the apparent temperature also goes up. So as our humidity goes up, the feel of the temperature goes up. Okay, so that's what's happening in my scatter plot. And it looks like these points are in a linear fashion. If I were to connect them or draw a line through them, it looks like it would be linear. And so down on figure 7, we have some examples of relationships that we see. And they want to know which ones are linear and which ones are nonlinear. And I think that that is pretty straightforward. If I can draw a straight line through the middle set of the data, we would say that this is linear. And this one, if I were to draw a line through the middle set of the data, this is nonlinear. Or, I'm sorry, this is linear. I'm thinking ahead. This one actually looks quadratic. And this one almost looks like maybe a chair function, so maybe that is cubic. And this one right here, we didn't talk about these in our functions, but this one looks exponential. All right, so just down here determining this part A is the only one that I see that is linear, and the other ones are not. All right, so if I look over onto the next page, we're going to take that information that we had, and I'm going to see if I can kind of squeeze these two together here. And it asks us to select 2 points to find of an equation of a line. So first what we're going to do is we're going to draw a line of best fit. Okay, so drawing a line of best fit. So I want to kind of go through the center part of a data, and this is a straight line, and I want to choose 2 points that are definitely on my data set. So that one looks very close, and it looks like maybe this one is very close as well. So the 2 points I chose was 0, 64, and this one was 80, I believe. 80 and 74. So those are the 2 points that I selected that were on my line of best fit. And again, that was 0, 64, and 80, 74. So we graph this line on our scatter plot. And now what we're going to do is we're going to find the slope of this line and actually write an equation of this line in a bit. So my slope is going to be the change in the y's over the change in the x's. And again, I used 0, 64 and 80, 74 as my 2 points that I'm going to use to find the slope. So the change in the y's would be 74 minus 64 over the change in the x's, which would be 80 minus 0. So this would be 74 minus 64 is 10 over 80, which is 1/8. So if I were to write an equation of the line, remember I need a slope and a point on the line. This one actually is my y-intercept, so I could use slope and y-intercept, which would just be y, well, let's start with this one. Y minus y1 equals my slope times x minus x1, point slope. So I would have y minus 64 equals my slope, which is 1/8 times x minus 0. And if I were to solve this for y, I have y equals 1/8 x plus 64. And this would be the equation of the line that's going through that data. All right, so at this point, what we're going to do is we are going to do this on Desmos. So I'm going to bring another iPad in here, and I'm going to show you how you can put the data into a table. The first thing we would do is touch the plus in the top left corner, which would give us a table. And in here, I am going to type in all of my x values. So there we go. I'm going to type in 0 and hit enter, and then 10 and hit enter. And you notice they're now suggesting, they think I'm counting by tens, which I am, and they're actually suggesting what numbers do you want to put in here. Whoops, and I don't need 110, so I'm just going to backspace. And then I only need to type in the y values. I go back up, just touch the cursor where you want to put your y values. And the first one is 64, and then touch the blue arrow key. That would give me enter. And then 65. 67, 68, 70, 1, 2, 3, 4, 5, 6, 71, 72, 73, whoops, 74. All right, so here I have the data that was in my table. Now that's put in Desmos, and if I were to zoom out a little bit, I would see that I have those points plotted right there. There is a way for Desmos to give us the equation of this line, and to do that, in line number 2, I'm going to write an equation, and I'm going to say that y1, and I'm saying y1 because these are my y1 values, and that's where I'm telling Desmos to go and look at stored values, because I could have other stored information in other areas. So I want Desmos to look at y1. And then I'm going to use this little squiggly line. It looks almost like a dash, but it's a little squiggly line. And then I'm going to have x1. Whoops, I'm going to go back. I'm going to do m for slope times x1 plus b. So I'm going to go back and grab a B here. And if you look, it drew the line through the points. And this is called a regression line. Okay, a regression line. And I'll write that down in a minute. But if we look down at this part right here, I'm going to zoom in here. Down at the bottoms, if you notice, I asked Desmos to give me an equation of a line, and I put it in the form of a linear equation. And the equation that they give me will have a slope of 0.12, and I'm going to round that off here in a second to 0.12, and a y-intercept of 64.4. All right, so I'm going to write that down. So putting that into Desmos, I have a slope of, me zoom back out so we can see. My slope was 0.12 and my y-intercept was 64.4. All right, so I'm going to also, on Desmos, I'm going to go back here and I'm going to also graph the line of best fit that we found. So that was 1/8, 1 divided by 8 times x, and it was plus 64, sorry. So 1/8 x plus 64. And if you look, and it's kind of hard to see unless I zoom way in, but we have a second line there, and it's showing us that the line that we created by picking the 2 points that we did was very close to what Desmos came up with. And if we zoom back out and looked kind of at a normal grid or normal axes here, it looks very close, as we can see that they're kind of lining up on top. All right, so two things I want to point out is the first line that we did was called a line of best fit. Okay, so that was the one where we took 1/8 times x plus 64, and we took the 2 points, calculated the slope, and found the y-intercept. The one that we put in the Desmos and have Desmos calculate for us is called a regression line. Okay, so that is the one that they told us our slope was 0.12 and my y-intercept was 64.4. All right, so two ways to do this, and you're going to be doing both ways. And we're going to try to check to see how close you were. Okay, so that is all for this lesson. I'll take this back here.